All right. Good morning to everyone who is working on this, the 13th Reachback of the quarantine period. This week is focused on algebra. So we have, I believe, 10 questions. So we'll start right into question number 1. Make sure you copy down the incorrect answers you had. Make sure you copy down what you should have written because it's important that you learn from your mistakes because Thursday's Reachback is going to be similar to this one, so you can at least use that as a reference in doing Thursdays. Your first question says, write as an algebraic expression. It says half of a number increased by 6. Let's add a little bit of space to this. Okay, that's a little better. So half of a number. So we think about half of a number. We would take a number and we would divide it by 2. Algebraically, a number, of course, is represented by the variable x. And we can say x divided by 2. That would be half of a number. However, a better way of writing half of a number is to take that x and to divide it by 2 like this, okay? So half of a number you can do either way. The second way is the best way. So half of a number increased by 6 would be the expression x divided by 2 plus 6. Now the other way you could have done it as well, you could have used a coefficient of a half, or you could have used a fractional coefficient of a half. All of those are exactly the same. All right, so all three would be good answers and would be appropriate. The second one says 3 decreased by double a number. So this time we need our constant first. So 3 decreased by double a number. Okay? And that's how you would write it. You'd write 3. And if you wrote this is not the same thing. Right? That's double a number decreased by 3. But 3 decreased by double a number would be your constant first and then your algebraic term second. All right, and your last one says a number increased by 7, then tripled. So a number increased by 7 would be the expression x plus 7. And if I triple that expression, I'm going to have to put brackets around it and put a multiply by 3. And what we ended up learning to do is that we use distributive property to expand it. So if we think about what that really is, that would be the same thing as also tripling a number plus 21, right? So a number increased by 7 tripled is this expression here. That's the answer you should have come up with, which is equal to, if you expanded using distributive property, this. But that's what you needed to write. Your second question asks you to take these algebraic expressions and write them in words. I'll spread it out a little bit. There, that's better. So this is a number decreased, not increased, but decreased by 1. A number decreased by 1. This is a number multiplied by 10. Or you could say 10 times a number. There's various ways you could read it, but those are both good ways. And you might have a different way that's right, but those two would be the most common ways of reading it. And the last one, there's two ways to say it. You can say a number divided by 3. Now again, you could also say x divided by 3. So x divided, or a number divided by 3 or x divided by 3 is one way, but a best way is a third of a number. Because remember, if you had x, and this was x here, x divided by 3 would be a third of a number. So the best way to read that would be a third of a number, or x divided by 3. Okay? Your next question gives you a one-step algebraic expression with a negative coefficient. So you're going to divide both sides by -2. You're going to get x equals a positive 10 because a negative divided by a negative is a positive. Question 4, you're going to multiply both sides by -2 because it's x divided by -2. Or remember, we could say a negative half of x, right? We could read it a negative half of x. So we're going to multiply both sides by -2. And we're going to get x equals a positive 40. Question 5. Here we have, I'm going to get my highlighter here. Here we have a constant, and our constant's the first term. And we have this unwritten -1 coefficient here. Okay, so what we're going to do first is we're always going to get rid of the constant first. Oops, that's my highlighter. And we're going to add 2 to both sides to get rid of your constant. Now look here. What we have left here is a negative x equals 9. Now, negative x is the same thing as negative 1x, but we never write a negative 1 coefficient. So what we're going to do to isolate is we're going to divide both sides by negative 1, and x will equal a negative 9. Okay, don't forget that. Most people forget about this, and they just put x equals 9, but it's a negative x equals 9, and you have to divide both sides by negative 1. Okay. Question 6, same thing. We have our constant first and our coefficient second. So the first thing we're going to do is we're going to get rid of that positive 2 constant by subtracting 2 from both sides. Negative 5x equals negative 5. Remember, the negative stays with the coefficient. Then we're going to divide both sides by the coefficient, and x will equal a positive 1. Question 7, we've switched it around. We put our variable on the right this time, not the left. So we're going to acknowledge that negative 2 is my constant, and I'm going to add 2 to both sides. I get 12 equals. Now look here. Here we have a negative fifth of x, which can be written as this, or it can be written as this. So the negative sign can either go with the numerator or the denominator, or it can stay in front of it. So we learned that the easiest thing to do is put it with the denominator. So we're going to, that's still a negative fifth of x. And now we're going to multiply both sides by negative 5. Right? And we're going to end up with x equals negative 60. Question 8, we have a distributive property question. There are 2 ways to solve it. Maybe what I'll do is I'll grab this and I'll infinite clone it. I'll clone it once and I'll do it 2 ways. So we'll do it both ways you can do it. The first way you could do it is expanding using distributive property. So you might have done this instead of having 5 groups of x minus 2, I have 5 x's and I have 5 negative 2's, which would be negative 10. That's expanding using distributive property. And once we have that, we're going to get rid of our constant and then get rid of our coefficient to give us the answer x equals negative 1. Now alternatively, we could have said if 5 groups of x minus 2 equals negative 15, then by dividing it both sides by 5, 1 group of x minus 2 will equal negative 3. And once we get to that, we're going to get rid of only the constant and say x equals negative 1. So no matter which way you did it, you end up with the correct solution that x equals negative 1. In question 9, we have the same thing. The only difference between question 8 and question 9 is question 8 was a positive multiplier of your algebraic expression. And this is a negative multiplier. So let's do the same thing. Let's take this. Let's clone it. Let's bring it over here. Take this one. Bring it over here. And we'll solve it both ways again. We'll expand using distributive property. So negative 10 multiplied by x is negative 10x. And look at this next one. Negative 10 times negative 2 is positive 20. A lot of people make the mistake of making it negative 20, but it's a positive 20. And once you get that, we're going to subtract 20 from both sides. Negative 10x equals 20. We divide both sides by negative 10, and x will equal negative 2. Okay? That's using distributive property. Alternatively, we could have divided both sides by negative 10. And instead of having negative 10 groups of x minus 2, we have 1 group of x minus 2 equals negative 4. Add 2 to both sides, and x will still equal the correct solution of negative 2. And finally, your last question is a tricky question. I don't even think we've ever done one like this, but we'll try it anyway. I mean, there's nothing wrong with trying something that's a little bit harder than normal, right? We'll expand using distributive property, so negative 2 groups of 5x and negative 2 groups of negative 2. Negative 2 times 5x is negative 10x, and negative 2 times negative 2 is positive 4. Subtract 4 from both sides. Negative 10x equals negative 14. And here we're going to divide both sides by this negative 10 coefficient. And a positive x equals a positive 1.4, because 14 divided by 10 is 1.4, and a negative divided by negative is a positive. Now alternatively over here, instead of having negative 2 groups of 5x minus 2, I'm going to divide both sides. Divide both sides by negative 2. Whatever you do to one side, do to the other. 5x minus 2 equals 5. Add 2 to both sides to get rid of your constant. 5x equals 7. Divide both sides by 5. And guess what? 7 divided by 5, let's just do it for fun. Let's use a calculator. 7 divided by 5 is 1 1.4. The same answer we got using distributive property. Okay, well, thank you guys for correcting, and for those of you who are still participating, thank you very much for taking your math seriously, and it will pay dividends next year, I guarantee it. Remember to stay safe, maintain social distancing, and as always, don't let your boomer parents drive you crazy.